So picking up where we left off, we're going to start going into some different types of triangles. And the first one we're going to do is talk about an isosceles triangle, one of my favorites. So first of all, what is an isosceles triangle? Well, you might remember that an isosceles triangle, whoops, let's see if we can type that over and drag that a little bit. An isosceles triangle is a triangle with two equal sides. So you see that in our picture over here, that I have this side that comes down from the left and the side that comes down to the right. Those are the equal sides, and they're called the legs. So the legs of the isosceles triangle are the sides that are equal. And the third side was just called a base. Now, are you okay if I turn my triangle this way and the base is on top? Or even worse, if the base is like somewhere over there, or if I make one of those legs look somewhat horizontal like that, it's all okay. The base is the side that's not equal to the other two. Now, the two legs form the vertex angle. So the vertex angle is the angle that's formed by the two legs of the triangle. So this angle is our vertex angle right here. And the other two angles, which are formed by the base and one of the legs, are called the base angles. Kind of makes sense about the base angles there. So what we want to do is we want to do some investigating with this here. So we're going to take a look at some geometry. Sketchpad real quick. Here we go. I got myself an isosceles triangle. You can tell it's isosceles because of the markings that are here and here. Those two markings being marked once each show that side AB is equal in length to side AC. AB is congruent to AC. And watch what's going to happen. Are you ready? Here we go. Oh, wow. Oh, baby. Unbelievable. What do you notice? Let's see, we're going to watch it one more time. So it looks like angle B goes over there, spins over, there's angle C, slides back. So if you were thinking that those two base angles, angles B and C, were congruent, bing, 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 winner, winner, chicken dinner. That's conjecture worthy, my friends. Yes. So we have what we call the isosceles triangle conjecture, which says if a triangle is isosceles, then its base angles are congruent. Pretty cool. So it's kind of like this, that if I know that I've got an isosceles triangle, what that means is that, and I'm just going to kind of do this. Let me see if I can just grab onto that. Okay, I'm going to do a little smartboard magic. We're going to clone that. We're going to drag it over there. But then we're going to erase that line there because I want that exact triangle. But I'm going to add something to it because the conjecture says if the triangle is isosceles, then the base angles are congruent. So as you see, there's another question on the bottom. What is the converse of the statement? Remember, the converse kind of switches things around a little bit. So maybe we're thinking that if the base angles are congruent, then the triangle is isosceles. Yeah, you're kind of close. The idea is that base angles only occur in isosceles triangles, and the converse is determining whether or not the triangle actually is isosceles. So maybe we want to say something like, if two angles of a triangle are congruent, then the triangle would be isosceles. And indeed, that's the one that's true. If a triangle has two congruent angles, then it is isosceles. Indeed so. So we'll get drawing that fancy picture again for us. Check it out. Now I'm going to draw a triangle, part of my ugly triangle there, and I'm going to draw it with two congruent angles. Okay, now be smart, Mr. Mahoney. Here we go. Let's do this. Let's clone that baby. Bam, there we go. I'm going to scoot that over there. And what this means is that it means that if two angles are congruent, the triangle is isosceles. So that's some cool stuff about isosceles triangles. I hope you find them enjoyable.